We will now determine the length of curve of this vector valued function r of t, which is given as r of t equals e power to t times of cos ti plus e power to t sin tj plus e power to t k, and within the interval from t equals 2 to t equals 4. So we can utilize this length of curve of vector valued function formula, which is given by integral from t equal to a to b under the root of dx over dt quantity square plus dy by dt quantity square plus dc by dt quantity square dt. So basically we have to determine the x of t, y of t, z of t from this vector valued function. So we will identify that x of t is basically the component of I, that is the e power 2t cos t is x of t, and then we have this y of t, which is the coefficient of j, which is e power 2t sin t, and then we have this e power 2t is the z of t. So now we will find the derivative of x of t, y of t, z of t, square them up, and then take the square root, and then we will integrate it. So I'm going to write down this x of t as just simply as x. So therefore x equals e power 2t cos t. So now we have to find the dx over dt. That is the derivative of x with respect to time. So with respect to the t. So this is, we have to use the product rule over here. So let me use the product rule. So I find the derivative of e power 2t. This will be e power 2t. And when I apply the chain rule, I have to differentiate the 2t, which gives 2 as the factor. So I put the factor 2 in front and then multiply with the other part, that is cos t, plus I keep the e power 2t as it is, and then find the derivative of cos t. Derivative of cos t is negative sin t. So we have just found the dx over dt. Since we need the square of this dx over dt, we will square it up. So we square it up like this. So this becomes 2 e power 2t cos t minus of e power 2t sin t quantity square. So here to square this, I'm going to use the algebraic identity a, that is a minus b quantity square, and this equals a squared minus 2ab plus b squared. So here we can consider this first term as a, the second term as b, and then we apply this algebraic identity to square this term. So therefore we will have a squared, which is the square of 2e power, it's 2t cos t. So when you square this 2 e power 2t cos t, the square of 2 is 4, and then square of e power 2t is e power 4t, and then square of cos t is cos square t. Then we have negative 2 times of a, which is 2 e power 2t cos t, multiplied with b is e power 2t sin t. Then plus we have this b square, that is we have to square this term e power 2t sin t. Square of this term is e power 4t, and square of sin t is sin square t. So this is the expression for dx over dt quantity square. In fact, this can be simplified a little further. So let's simplify this. We will have a dx over dt quantity square. This equals, this is 4 e power 4t cos square t. Now we have a product of this term, that is 2 times 2 is 4. So this becomes negative 4. And we have the term e power 2t multiplied with e power 2t. This will give e raised to the power of 4t. And then we have the term cos t multiplied with sin t is, I can put this as sin t cos t, plus the last term is e power 4t sin t. So this is the simplified form of dx over dt quantity square. And now in the same way, let's find the dy over dt quantity square. So I'm going to copy this first, that is y of t equals e power 2t sine t. So let me write down here. So we have y equals e power 2t sine t. And once again, we have to apply the product rule to differentiate this expression. So I write down dy over dt equals, first I find the derivative of this e power 2t using the chain rule. So when I do that, I get 2 e power 2t multiplied with sine t, plus I then write down the e power 2t multiplied with the derivative of sine t, which is cos t. Now we will square this up. So we have to square this up. And here I'm going to use this algebraic identity, that is a plus b quantity square equals a square plus 2ab plus b squared. So I'm going to consider this expression as a and another expression as b and apply this identity. So when I do that, first I have to square a, that is the square of this term 2 e power 2t sine t is square of 2 is 4 and square of e power 2t is e raised to the power of 4t. Square of sine t is sine squared t. So I have written this a squared plus first, then I'm going to write down this 2ab. So it will be 2 times of a is 2 e power 2t sine t multiplied with the b term is e power 2t cos t, then plus b square. So let me square the b term. This will be e power 4t. Square of cos t is cos squared t. So we will get this simplified. This is cos squared t. We'll simplify this further. So this first term remains as it is. That is 4 e power 4t sine squared t. This will be plus 2 times 2 is 4. And once again, we have e power 2t as well as e power 2t. So when you multiply this, we get e raised to the power of 4t. And then we have sine t cos t. So we will have sine t cos t plus the last term is e raised to the power of 4t cos squared t. So this is the expression for dy over dt quantity squared. Now we will find the dz by dt. So we have to get the dz by dt. So that is z is e power 2t. So let me write down the z here, e power 2t. I have to find the derivative, that is dz by dt. This equals e raised to the power of 2t. And when you apply the chain rule, we get 2. So it's basically d 2 e power 2t. So we'll also square this up. That is, we get dz by dt quantity square. This equals 4 e power. This will be 4t. When you square e power 2t, we will get 4t. Here we have the all the three expressions for dx by dt quantity square, dy by dt quantity square, and dz by dt quantity square. So we can now find the sum of these three expressions, that is dx by dt quantity square plus dy by dt quantity square plus dz over dt quantity square. So let's add this. Observe that when we add all these three expressions, we have to add the right side of these expressions. So here we have 4 e power 4t cos square t and 4 e power 4t sine square t. So we can factor the 4 e power 4t, and then we will have cos square t plus sine square t. So the trigonometric expression or the Pythagorean identity is sine square t plus cos square t equals 1. So therefore, when you add these two expressions, we will get only 4 e power 4t. And this expression, negative 4 e power 4t sine t cos t and 4 e power 40 sine t cos t, these two are like terms. However, they are opposite in sign, so they cancel out each other. And we also have the another expression. So this is also basically sine square t. So we have e power 4t sine square t and e power 4t cos square t. So when you add them together and using the Pythagorean identity, we will have e power 4t. And finally, we have the dz by dt quantity square, that is 4 e power 4t. So this is the simplified expression when you add all the three quantities. So now these are right terms, that is 4 e power 4t, e power 4t, and 4 e power 4t. So when you add all these three, we will get 4 plus 1 is 5, 5 plus 4 is 9. So it's basically 9 e power 4t. And now in the integral, we have to take the square root of this expression. So let's take the square root of this sum. So we have to take the square root, which means we will also have to take the square root. So when we do that, the square root of 9 is 3, and square root of e raised to the power of 4t is this power will get half. That is, we have to divide the power by 2 when you take the square root. So it becomes 2t. So therefore, this is 3 e power 2t. So we got the expression for the quantity under the root of dx by dt quantity square plus dy by dt quantity square plus dz by dt quantity square equal to 3 e power 2t, which means we can substitute into the length of curve formula. So let's do that. So therefore, the length of curve, let's me denote that by letter L. This is equal to, we have to put the interval, that is t raise goes from the interval from the values t equal to 2 to 4. So the lower limit is 2 and the upper limit is 4. And then we have to substitute this value which we have found out, that is 3 e power 2t dt. So let's do the integration of this integral. This 3 is constant. We can factor it out of the integral, and then it becomes integral of 2 to 4 e raised to the power of 2t dt. So we just have to integrate e raised to the power of 2t. Integration of e power function, exponential function is basically the exponential function. So we put e power 2t first, and then we have to divide by the differential coefficient of 2t. So when you differentiate 2t, we get just 2. So you have to divide by that component. And then this has to be evaluated within the limits of 2 to 4. So let's evaluate this. So this I can combine this denominator 2 with this 3 as 3 over 2. And then this becomes e raised to the power of 2t within the limits of 2 to 4. So we can substitute the upper limit. When we substitute the upper limit, we get 3 by 2 e raised to the power of 2 times of 4 and minus of e raised to the power of, now I substitute the lower limit, so this becomes 2 times of 2. So finally, which this could be simplified as e raised to the power of 2 times of 4 is 8, and e raised to the power of 2 times of 2 is 4. So this basically is the length of curve. And to find the decimal value of this length of curve, we can plug this into the calculator. And when we do that, we approximately get the value as 4,389.54 rounded to two decimal places units. So this is decimal value and this is an expression value. So this is the length of curve for the given vector valued function.